Hello students, welcome to IMS GATE Academy. This is Gopal. In the last class, I took the number of problems on analog circuits. But I selected the topic of diode circuits and also BJT and also 2 or 3 problems from the feedback amplifiers I did it. In this session, I am going to do the problems from feedback amplifier, MOSFET, and also from the operational amplifier. These are the 3 topics I am going to touch. Okay then? Yes, the subject is analog circuits. Analog circuits. Now, today in the today's session, we are going to do number of questions from the operational amplifier and MOSFET. I said the now. Understand the now. One by one, we can do the now. This is one of the questions from the operational amplifier. But by what he is asking in the question, please watch it. Once you watch and start the work, I am giving some time. Please try to solve with your own effort. If you don't get answer, I will start my work. Can you try this question at first? I am requesting every one of the students, please put the focus, the concentration. If you don't put the concentration 100%, you cannot solve these questions. Understand my point now? Try to focus attention. Anybody can do this question? Anybody can do this question. If not possible, I will do it. Okay, I will do, please watch. The V0 of the ideal op-amp circuit shown below. This is one of the question it is given only here now. But in the problem, it is specified clearly the given operational amplifier is ideal. Given operational amplifier is ideal here. When we can say, but whenever the operational amplifier is ideal, we know very well the input impedance of operational amplifier is infinity, very high input possible here now. Output impedance is approximately 0 is possible. This is for the ideal op amp, you know very well. The gain also infinity is possible here now. This network, what now, slightly we can change, we can redraw this diagram and we can start the what now, work. How we can redraw this circuit, please watch, I will do. The minus and plus. This is connected with 1 ohm resistance. This is connected with 1 ohm. The given Vi is input voltage is common for these two. Common for these two only now. This and this. This is a common voltage. So I want to take 1 ohm here connected. Vi I want to connect here now. The positive terminal is connected with a resistance of 10 ohm. Here connected with 10 ohm. It is connected with D, you are saying. The option D is 0. Exactly correct. 100% perfectly, no doubt. Yes, one student gave. Answer is 0. Okay, no problem. I will do, please watch. I got here 1 ohm resistance. This is 1 ohm resistance. It is also Vi. This voltage is common for both. The feedback resistance is given 10 ohms, you know. This is nothing but V0. This is connected with 10 ohm resistance. This is connected with 10 ohm resistance. the given problem I have written like this. That means Vi I connected to the what are these and these terminals only now. For both terminals here I have taken now. Under virtually ground concept, we want to do the question only now. This potential and this potential will be same. Under virtually ground concept, these two potentials are same only now. The student will get a doubt. How these two potentials are same, sir? In a problem clearly given, it is nothing but ideal op amp. The differential gain, that means V naught equal to, for ideal op amp, AD into VD. Everybody knows. For ideal op amp, V naught is nothing but AD into VD. But here the VD is nothing but difference of voltage. For positive and negative, these two potentials are same. V plus, this is nothing but V plus, this is nothing but V minus. I have taken V plus minus V minus I have taken here now. V minus I have taken here now. Just wait. V minus. I say V plus minus V minus I want to know down here now. Every student knows very well, for ideal op amp, differential gain is nothing but infinity only. The gain is infinity for ideal case. When AD is infinity, V naught equal to what I can write? AD is infinity here, V plus minus V minus I can write. V plus minus V minus equal to what you will get? V naught by infinity. Something by infinity is nothing but 0 only available. Here now I can say V plus and V minus are equal. V plus equal to V minus here possible for ideal case. This is not applicable. V plus and V minus are not equal for non-ideal case. It is allowed only for what? Ideal case only now. In the ideal case, V plus and V minus are equal means I can say this potential equal. What is this potential? I want to find. This potential I want to take it as a Vx. Even this potential also Vx we can put directly. How I can find the Vx value here? Just you watch. As per voltage division formula, we can get Vx. That means whenever this network is given here now, the current will pass this side and diverting this side only. No current will pass. What now? Sound is low, sir. Sound is low, you say. Yes, 1 minute. 1 minute I will ask now. Sound low వస్తుందండి అందులో వస్తున్నారు. Yes, what is Vx here you find. Now is it audible or not audible? Sound is, are you receiving the sound or not? But there one student said sound is low, sir. Is it audible or not audible now? Is it audible or not audible? Please respond, then I can understand. Anybody can say, is it audible or not audible? Nobody is responding? Not audible. Audible or not audible? Shall I start then? Yes. What is Vx here? Vi into 10 by, here the resistance is 1 ohm, 10 plus 1 is nothing but 11. Vx we got as 11. 11 only we got it now. Once we got the 11, Vx into 10 by 11, Vx we got now. Same voltage we can have here also then now. This current equal to, we know, this current. Whatever the current, it goes this side, diverting to this side also. I say, suppose this current is nothing but the I1, I for example I have taken. This is IF. I and IF are same. No current is going to pass this side. This side it won't pass. Why it doesn't pass up? Because operational amplifier can have input impedance of infinity. When the input impedance is high, we cannot find any current in this direction only. So I say I equal to IF is possible in this circuit. These two currents are same. What is I here? What is I? I is nothing but Vi minus Vx by 1 ohm. Vi minus Vx is nothing but 10 Vi by 11. Divide by 1 ohm. Divide by 1 ohm only here now. This is equal to IF. What is feedback current here now? The IF is nothing but Vx minus V naught. Vx is nothing but 10 Vi by 11 Vx minus V naught. Divide by 10 ohms it comes. Such a way we can get. This I want to simplify. In what way we can simplify? Here 11 into Vi, 11 Vi I can get here now. 11 Vi here I can get. Minus 10 Vi here possible. Minus 10 Vi here possible. Divide by 11. But in this side, what you will get here now? 10 Vi minus 11 V naught divide by 10 into 11 only. 10 into 11 is available. On both sides, I can cancel 11 and 11. These two values I can cancel. Finally, what I can get now? This side, if I multiply it with 10, I can get 10 into 11, 110 Vi. 110 Vi here possible. And 10 into 10, 100 Vi here possible. 100 Vi here possible. This side I can get, what I can get here now? 10 into 10, 100 is available. 100 Vi, sorry. On the right hand side, what I can get here now? 10 Vi minus 11 V naught is possible here now. Now we can get answer. 110 minus 100 Vi, how much? 10 Vi is possible here now. I can say here available 10 Vi. This side I can get the 10 Vi. And next one here now, this is a 10 Vi I am getting here now. This side what I can get? 10 Vi minus 10 Vi minus 10 Vi minus what I am having here now. Please watch. 10 Vi minus 11 V naught we got now. 11 V naught. This is 11 V naught we got. Then I can get answer. But on both sides, I can cancel 10 Vi and 10 Vi. If both are cancelled, what I will get? V naught is nothing but how much? 0 volt only possible here now. That is the V naught is available here now. That way, the value we can determine here now. So finally, which option is correct here now? Which option is correct? Is it a 10 volt? Is it a what now? 11 Vi, 10 Vi, option C Vi, option D is 0. We can say exactly option D is correct here now. This option is correct. This is the way we can solve this question. I hope students follow this question. Any student having any doubt regarding this solution? Any student? This is the way to tackle this question, I can say. Now we can go to next question. Yes, this is one more question from the operational amplifier. This is one more question. Initially, you make an effort to get answer for this question. You take some time and try to give your answer for this question. What answer you can get for this question? Please make an effort to get answer. Start. I will wait for some time. Please try to complete this question. If you don't get, I will help you. The initial trial is yours. What answer is possible from this question? What answer is possible? Any student can respond? Any student can respond? What answer we can get from this? Okay, I will do here now. Please try to compare this answer. You also start doing this question. If you are getting answer means immediately you message it. We can compare, no problem. Understand that? Yes, I will start this question. But the output voltage of the following circuit, assuming ideal behavior, is dash volts. Even in this problem also, it is given operational amplifier is ideal. This is ideal operational amplifier. Both operational amplifiers are ideal only here now. He is asking to find out the value of output voltage V0. What way we can find the V0? You please watch, I will do here now. If you want to find the V0 value, this V0, same V0 is going to exist here now. Same V0. We don't have any resistor in the middle. Same V0 we can have. Here the V plus is nothing but V0. Even V minus also same V0 is available. V minus also same V0 we can get here now. Under virtually ground concept, this potential and these potentials are equal only. 1, yes, very good, exactly 1, 100% perfect, very good. Good work you did. Exactly, one student gave one answer, 100% perfect. Yes, very good. Such a way you try to respond. If you are responding means very happy. I will also get more interested, understand my point now. Yes, I will also do. And also here the V0, but this is V0 means this is also V0 I said. Initially what I will do, what is V01 I will find. How I can find V01, sir? By using this node, I want to find the V01. By using this node, I wish to find this voltage. By using the, we can do next ones now. By using this node, I'm going to find the V01. Next, what I will do, by using this node, I can measure the V0 here now. Try to understand. Clearly, I will give the concept. Initially, I want to apply the nodal analysis. Nodal means we can take the direction of current any side. It is a conventional, for our convenient purpose, we are going to put the current directions only. That is said to be conventional direction only now. I say, according to nodal analysis, summation of all the currents equal to 0. I am taking current away from this direction. Otherwise, you can take this current equal to that side, it goes only, no problem. I have taken away from that point. But we cannot find any current through the what now? Operational amplifier. Why it doesn't flow current? Because ideal op amp can have infinite resistance only now. Because of that reason, it doesn't allow any current to pass across this direction only. Now, the point what I wish to say, as per the nodal analysis, summation of all the currents equal to 0. V0 minus 1, I am taking here now like this. V0 minus 1 divide by 1K, because this voltage minus this voltage by 1K. This is by 1K I have taken, plus summation of all the current 0 I said. What about this current? V01 minus 1 by 4K. Sorry, this is the node only, sorry. V0 minus V01. V0 minus V01 divide by what resistance we are having, this side, 2K resistance only. Yes, I can put 2K. I said just now, According to nodal analysis, summation of all the currents equal to 0 only now. So this side current plus this side current equal to 0. I want to put this as 0 only now. And K cancelled on both sides, no doubt. My aim is to find out the what? V01. When I cross multiply 2V0 here minus 2 plus V0, 2 into 1, 2, 2V0, V0 minus V01, that equal to 0 is available. But my aim is to find out the V01 because by using the V0, I wish to find the V01 here now. I can find what is V01 here. V01 means how I can get V01 equal to 2V0 plus V0 is nothing but 3V0 here minus 1 minus 2 we got here now. Yes, that much V01 we are getting from this one. Third or not, 3V0 minus 2 we are getting. Is it right or not? Others can check this now. Please check it. Next one. By using what now? This node, I want to find the V0. Again, I want to apply the nodal analysis. This current plus this current equal to 0. Away from the node, directly we can take. It is not a problem. It is not a mistake. This side current means 1 minus V0. I want to take 1 minus V01. 1 minus V01. V01 is nothing but 3V0. I can write 3V0 minus 2. This minus this, divide by 4K. Divide by 4K. I can put here now. Summation of all the current 0 I said plus this plus. And one more current I can take in this direction only now. In this direction 1 minus V0. I can note down 1 minus V0. 1 minus V0 divide by how much? 8K is possible here. I can put 8K. Summation of all these currents equal to, I said, 0 itself. Yes, directly I can put 0 here now. And I can cancel here K and K. And 4 2 times we can cancel here now. 4 2 times I can cancel here now. 2 times I can cancel. When I cross multiplied, I will get the V0 here now. Just cross multiply 2, 1 minus 3V0 here I will get. Here I will write now. Minus 3V0. Minus 3V0. 1 plus 2, 3 here. 1 plus 2, 3 plus 1 minus V0 divided by 2 we are getting. That equal to 0. Take LCM and get answer. 2 3 is 6 minus 6 V0. 2 3 6. 1 minus V0 I can get here now. That equal to how much? 0 it is available. I can write minus 6 V0 minus V0 is nothing but 7 V0 equal to how much? 7 V0 equal to 7 is available here now. What is V0? If I ask, anybody can say 7 by 7, 1 voltage is available. That is the output voltage from the given problem we got it now. That way we need to tackle this question now. Just we are applying in any problem nodal analysis only. That is the powerful tool to find out the what now? Required parameter from the operational amplifier. For ideal case, we can apply what now methodology in this way. I hope the students could understand very perfectly. I hope now. Do you have any doubt? Means immediately you can arise it. Anybody having any doubt regarding this solution? Anybody? Shall I go to next question? Please respond. Shall I go to next question? Yes, we can go to the next question now. Yes, this is one more problem from the operational amplifier. You please try to take some time to give answer. Yes, already one student has done the what now answer very perfectly. Can you try this time also again? Can you try again to get answer for this question? What answer is plausible? Which option is correct? Please make an effort. Start your work. Start your work. But I want to give you some time. Please try to complete this question. If you got answer, very happy. Anyhow, I am going to do shortly this problem. Initially, I want your answer. The work is required from your side also. Please start your work. Anybody? Yes, he is giving the option C. Just I will check the now. Option C. Yes, very good. Exactly correct. Yes, Herculean. Exactly is doing the what now? Exactly is getting the answer now. 100% perfect. Option C is 100% perfect. Minus 3 milliamperes. That is the work is required from the students. The same way other students also can make an effort to get answer. Please try. Try to practice. Now, in this case, how I can get the value? What is the question given here now? What is the value of I naught in figure shown below? Is asking to measure this current how much? This current is required. I naught is must. But I want to make an assumption. This voltage is nothing but V naught itself. This voltage is to be taken as a V naught only now. I can say V naught is nothing but voltage across 2 kilo ohms. Across 2 kilo ohms, I can say here now. How I can find? Because V naught also very important. Without V naught, we can't get the value of I naught. That is very important here. I say this voltage initially you find. These are all ideal op amp only now. This voltage also very important. This voltage I wish to take it as a Vx. Sir, why this voltage is required? You can understand now. You can understand. How I can get Vx? When we are giving the what supply of 1 voltage, the current will pass in this direction only. It will not divert to the what this side. No current will pass because input impedance of operational amplifier is infinity. In that case, we cannot find any current this side. Total current will be diverting this side only now. How we can measure Vx? According to voltage division formula, I can measure Vx. 1 into supply voltage 1. 20 by 20 plus 20, 40. I can cancel 0, 0. 2 times it is cancelled. Finally, Vx equal to how much? 0.5 volts I can get. Yes, we are getting Vx of how much? 0.5 voltage. By using this voltage, we are going to determine I naught value. How, sir? You got it. If it is a Vx is a 0.5, this is also 0. Current is passing this side and diverting to this side. Can you say what amount of the current is passing this side? Same 1 milliamperes. It doesn't flow this side because input impedance of operational amplifier is infinity, I said already. So this current also same 1 milliampere. Even you have taken here, this current is same 1 milliampere only. Now the point what I wish to say, by using this node and this node and this current, I wish to measure what is V naught. We know very well this current is 1 milliampere. Current across 4.5 kilo ohm, how much? If I ask, anybody can say 1 milliampere equal to 1 milliampere equal to difference of this voltage by resistance. Vx we know very well. Vx is 0.5. I can put. This is 0.5 minus how much? V naught. 0.5 minus V naught divide by how much? Resistance we know 4.5K, that I can put it as this. 4.5K resistance we got here now. Now 0.5 minus V naught equal to how much we can get here now? 0.5. Please wait. .5. I'm writing here now. 0.5 minus V naught. I wish to find. Kilo means 10 power 3. 10 power 3, 10 power 3, 10 power minus 3 cancel. I'm getting here now 4.5. I will get here now. This is 4.5. What is V naught? Yes, V naught equal to 0.5 minus 4.5. Finally, this value V naught is nothing but minus 4 volts we can get. That much amount of V naught we are getting from this problem. Sir, why this V naught is required? Once this V naught you got means the current in which direction it flows across these 2 kilo ohm we can identify easily now. Current always passes from the higher potential to lower potential. Everybody knows clearly. From that point, this side we are having the zero potential. This side negative potential. 100% the current direction is to be taken this side only. That current, how much are? That current, this current is nothing but how much we can say? This current I want to measure. Suppose I have taken this is Ix for example. What is Ix? If I ask, Ix is what? Or directly we can find, no problem. Ix also not required. Still easily we can find you watts. I say Ix also not required. Directly we can find. This current plus this current plus this current equal to 0. According to nodal analysis, summation of all the currents equal to 0. We know very well. This current is I naught. Yes, I can put I naught. The current which comes from this side is 1 milliampere. Yes, I can put 1 milliampere. 1. Finally, we can take milli only. 1 milliampere. And also plus Ix. Plus Ix. Summation of all these currents equal to 0 only. So, I naught here plus 1 here. Ix is nothing but 0 minus V naught. Yes, we can write 0 minus V naught. V naught is minus 4. Minus minus plus 4. Divide by resistance is nothing but 2K. This is nothing but 2K. I am getting like this now. This is equal to 0. Anyhow, this also exactly means 1 milliamperes I said now. This is a 1 milliampere only. Understand my point now? Exactly. This is a 1 milliampere we are having now. Now we can get answer here now. I naught. I want to find the I naught plus 1 milliampere. This is a 4 by 2, 2 milliamperes here. 2 into 10 power minus 3 equal to 0. And I can get what is I naught here now. I naught is nothing but how much? 1 plus 2, 3 minus 3 milliamperes here possible. Such a way, this problem is to be tackled. Such a way we can do. Which option is correct? Option C is correct. Exactly. This answer is correct. So, what value of I naught had in this particular problem means minus 3 milliamperes only. Such a way we can do. Did you understand this method? Followed or not followed? Anybody having any doubts regarding this problem? If there is any doubt, please arise. We can discuss then. Followed this? Just I applied nodal. But from the operational amplifier, 100% guarantee question. Even for the electrical or electronics or instrumentation. What now? This is the what now? The problem from the operational amplifier is 100% expectable only now. 100% only. 99.9 also we can not say 100% expectable only now. Understand now? That's why you pay more attention on operational amplifier. That's why I'm doing the more number of questions from the op amp. Understand now? Later on we can see problems on MOSFET also. Yes, we can go to next question. Yes, this is one more question. Can you try at first? What answer is possible from this question? Please put an effort to get answer. If you got answer, very good. I will give you some time. Please make an effort to get answer. Start doing this question. Which option is correct? You identify. You can have a good practice in this session. But I want to wait for some time. Please do this question. Anybody? Start doing this question. Even you are given one op amp or 2 operational amplifier or 3 op amp, no problem. The methodology is same. Methodology is same only now. Easily you can get answer now. Please start doing this question. Any student getting answer? Shall I do otherwise? Shall I do or shall I wait? Any student? Can you message? Can you message? Yes, I will do. You also parallelly you do it. If you are getting means you immediately you give the solution. The output voltage V naught of the below circuit is asking. Yes, once yes it is given. I think now Herculean given as a option B is correct. I will check option B. 100% perfect. Yes, very good. One student is what now putting more efforts to do the problems only now. Good effort you made. 100% perfectly now. Yes, I will do here now. Please watch. Just I will explain and I will do this question. The output voltage V naught of the below circuit is asking to find the output voltage. Not given. Even not given, we need to assume they are ideal op amp only now. Sir, not given ideal op amp, sir. How can you say it is ideal, sir? But the problem, if you are given any any differential gain is given, you think it's so. For example, if you are given any differential gain, 30, differential gain is a 20, even it is given 1,000 or 10 power 5 or 10 power 6, something it is given means, you can say it is not ideal op amp. Whenever the differential gain is given in the problem, at the time we can say it is not an ideal op amp. And also one more point, whenever common mode rejection ratio is given in the problem, common mode rejection ratio and given means 100%, common mode rejection ratio also you will give along with the differential gain only now. In that case also we can say directly it is nothing but non-ideal op amp only now. But in this problem we don't find any CMRR, we don't find any differential gain. At the time we need to assume the given operational amplifier is nothing but ideal op amp only now. Understand my point now? So even not specified, we got an idea, it is an ideal op amp. Then we can start our work. What way we can do? We need to find at first this V1. Directly V naught is available. What V1 is possible from the given network? That is more important at first. After getting the V1, by using this V1, I can find the V2 again. Again, I can find the V2. By using the V1, I can find the V2. By using the V2, I can find the V0. That way, we can get the answer only now. They are all dependent, one over other only now. How I can get V1? But can you say what is the name of this network? Anybody can say what is this network? What network is given here? Anybody can say? What is the name of this network? Anybody? Anybody can say what is the name of the network it is given here? It is given non-inverting operational amplifier. The first one which is given is non-inverting operational amplifier. In the non-inverting operational amplifier, it is a 1 millivolt. V plus is nothing but 1 millivolt. Even this voltage also same 1 millivolt. It is also 1 millivolt, no doubt. Both voltages are same only now. According to the what known non-inverting operational amplifier, I can find what is V1. What is V1? I can determine easily now. How I can find? Everybody knows. From the non-inverting operational amplifier, output voltage is calculated by 1 plus R2 by R1 into what? Vx. That Vx is nothing but this voltage only. The resistance we are going to put as a R1 value. This we are going to take it as a R2 value only now. Then we can determine what is V1 here now. How we can determine? 11 volts is the answer, sir. Option 11 is there. 11 volts are there. 11 is not there here now. There is no 11 here now. We don't find any point. Yes, what you gave is correct, I think now. B is a 1.1 is a 100% perfect, Herculean. 100% perfect. Okay, we can check up. No problem. I will check here now. Understand. The V1 equal to 1 plus R2 by R1 into Vx, no doubt. So I can write V1 is nothing but 1 plus R2 by R1, 100 by 10. Kilo cancel, 100 by 10. I will get here. Vx is nothing but, how much Vx we are having? 1 millivolt. This voltage is 1 millivolt. We are having 1 millivolts. When the calculation, 10 means what? How many times 0, 0 here cancel? This volt, what now? These are 2 zeros are cancelled here now. And 10 by 1, 10 plus 1, 11 we can get now. V1 is nothing but 11 millivolts we are getting. V1 is nothing but 11 millivolts. Please cross check. Are you getting 11 millivolts? 11 volts answers are option 11 is there. Yes, anyhow 11 volts we are getting at V1 only now. So V1 equal to, we got as a 11 volts, 11 millivolts only now. With what sign here now? 11 millivolts positive value only now. And next one, after getting the V1, I wish to find the V2 value now. Can you say what is this name of network? What network it is given here? This network is nothing but inverting operational amplifier. Second one is nothing but inverting operational amplifier. This is inverting operational amplifier. This is nothing but non-inverting operational amplifier only now. But in the inverting operational amplifier, everybody knows V2 is nothing but minus of R2 by R1. Everybody knows. R2 is nothing but the resistance. R2, 470 K. This is also K, divide by 4.7 K. K cancel, 4.7 into input voltage of sir, MIT Manipal College kaisa hai? Okay, we can check now. First we can do this problem. Let me complete this now. V2 equal to minus 470 by 4.7 into V1. What is that V1? We got already what? 11 millivolts. Into 11 millivolts. 11 millivolts we are getting. When you are using the calculator, V2 is available, the V2 value is available, minus 110, 10 times it is cancelled now. Minus 110 millivolts we can get. Minus 110 millivolts you will get here now. That is the V2 value. And next one, this V0 I can get by using the what now? V2 only now. By using this V2, I can get the V0. But again, one more operational amplifier we got, that is nothing but what? Inverting operational amplifier again. How we can get from this onwards V0 value? I can get V0. V0 is nothing but 22 by 2.2 minus 22 by kilo, both are kilo, divide by 2.2 K, 2.2, kilo cancel. Multiply by what? V2. V2 is nothing but minus 110 milli 10 power minus 3 you can get here now. 22 by 2.2 means 10 times you can cancel. Yes, we can cancel now. V0 equal to minus 10, minus plus here. 10 into, what is available? 10 into 110 into 10 power minus 3 means 0.11 you will get. 0.11 you will get here now. 0.11 multiply 10 power minus 3. 0.11 if you multiplied with 10, what you are going to get? 1.1 volts it is available. You will get 1.1 volt only now. So 100% option B is correct, I can say. Option B is correct. Yes. Herculean, already you gave it what now? Option C. Again you changed, I think it now. 470 by 4.7 into 472 by. Finally, what answer you are getting? Check it now. Exactly it comes same only now. Check it now. Where is 470 by 4.7 into 100. 100 where you are getting? We don't get it anywhere. 11 millivolts only. We are getting 11 millivolts only now. Minus 470 by 4.7 into 11 millivolts only now. 11 millivolts, not 100 there. Understand now. Calculation wrong, sir. Okay, no problem. In V2, understand now. But anyhow, this is correct. Is it right or not now? What we did? Are you satisfied with this answer or not? Are you satisfied with this answer or not? Please tell me. Any doubts anybody has got regarding this problem and solution? Okay, anyhow 1.1 volts is 100% perfectly now. Understand now. Such a way we can do. Yes. Yes, I will go to the next problem now. Yes, this is one more question. This is one more question. Yes, can you try this question again? I will give you some time. Please try to tackle this question. Which option is right? Please put an effort. Which option is right? You try to get answer from this. Anybody? What answer is possible from this network? What he is asking, what we need to find, please do it. BTech, CS, MIT, Manipal, is it good college or not? Good college or not? Okay, just wait, I'll get the information from the what now? Management, no problem there now. Understand? We can discuss that later. Anybody? Anybody can get? Please solve this question and give answer. But I want answer from the students. The current gain not given, sir. Current gain not given. Yes, not given only. But anyhow, that is the problem only. The beauty of that problem is that only here now. The beauty of this problem is current gain is not given. In that case, how we can determine? That is more important. That current gain is given means anybody can do very directly. Anybody can do only now. The beauty of the problem is only when it is not given current gain. What to do is more important. Please think it. Please think it. Yes, very good. What condition need to find, sir? Yes, I will explain otherwise. Okay, I will do, no problem. No, I will explain now clearly. You will get the idea. What is asking in the problem? A circuit is shown below. The largest value of RL that can be used, the largest value of RL that can be used only. Largest value, catch my point. Largest value of RL that can be used in the network only now. But in the problem, you try to identify across 2 kilo ohms, some current is passing this side. This current and this current are same or not same? That is my first question. The current across 2K, current through the what not transistor are same or not same in the problem? That is my first question. Anybody can give clarity? Same or not same? Two currents are same or not same? 100% it is same. Why, sir? Why it doesn't divert any current, sir? Because this is the wire is connected to what? Operational amplifier. The operational amplifier can have input impedance of infinity. Input impedance, what? One student gave, what is answer? 5 milliamperes it is given, I think. 5 milliamperes. Current you are giving? Yes, we can do, I will do. And you can compare. Finally, you compare. This current is passing through the 2 kilo ohms, same current will go down also. No current is going to divert this side because operational amplifier can have infinite resistance only. At the time, no current is diverting this side. 0 amperes of current is passing this side. So if this current is IC, IE, emitter current, even this current also emitter current only. It is not going to divert any current this side. In the problem, beta is given or not given? Beta is not given. Whenever beta is not given, we need to assume IE and IC are approximately equal. I say IC is approximately equal to IE. Is approximately equal to IE only now. Understand my point now. First of all, what is that IE we can determine? IE is nothing but 12 volts, this voltage only now. 12 voltage here given only now. But any voltage is given here now, 12 voltage is given, here it is given 2 kilo ohms only now. This is nothing but the V plus is given 2 voltage here now. V plus is 2 voltage. V minus also same voltage, 2 voltage here now. Same voltage it is maintained here also. same voltage will be maintained here also then. Hence, we can find the IE. How we can find 12 minus 2? Yes, 12 minus 2 divide by 2 kilo ohms. By 2 kilo ohm I have taken. 12 minus 2 is nothing but the 10. 10 by 2k is nothing but the 5 milliamperes. 5 milliamperes. Yes, you gave the 5 milliamperes. 100% perfect now. Yes, one student, Herculean, gave the 5 milliamperes. 100% perfect. 5 milliamperes we got. But these IE and IC are approximately equal, I said. Those two are approximately equal. Next point, you try to catch. To find this RL value, what is must? Voltage is must. Current we know, but we don't know what is the voltage here now. Even this current also same, I said. IC only now. The largest value of RL here required. When largest value of RL is possible, when beta is not given, you have to assume. The transistor is in saturation mode, we need to assume only. Sir, not given, sir. If not given, beta is not given means VCE we cannot calculate. VCE we cannot calculate. Because unknown values are VCE is unknown, RL is also unknown only. Two unknowns are existing. We should make an assumption the transistor is in saturation. When the transistor is in saturation, we are going to find the current will pass this side only now. Some current at the saturation level, what current is available, you have to get only now. By using that current only now, we need to measure the what now. But that means when it is in saturation region, we need to find out the voltage only now. We need to know the voltage in between these two. Emitter and collector, how much voltage is possible. You need to know only now. Catching or not catching? I say, in this problem, transistor is in saturation, we need to assume. Everybody knows, when the transistor is in saturation mode, VCE is to be taken as a what now? 0.2 voltage only now. 0.2 voltage only. But in ideal case, what they will say, when it is in saturation region, the transistor can act as a what now? Just a short circuit only now. Still, in ideal case, if it is taken, it can act as a short circuit. 0.2 is a very small. At the time, they will assume this voltage is approximately equal to 0 only now. We collector to emitter voltage. When VCE value is approximately 0 means what is going to happen now? Same voltage, the same 2 voltage will be dropped across the RL itself. It doesn't have any other voltage because from here to here we are assuming the 0 voltage only. Why it is taken, sir? Because we made an assumption the transistor is in what? Saturation mode. As it is in saturation mode, sir, we need to take the 0.2 voltage. That voltage is a very small, we are neglecting. It's not a mistake. When it is neglected now, 0 voltage only here, the short circuited means now. Now I can measure what is RL directly. How I can measure RL? Voltage across RL is nothing but same 2 voltage. This 2 voltage will be dropped across this RL. So 2 volts divide by current. What current is passing here now? IC. That IC is nothing but 5 milliamperes. 5 milliamperes it is possible. 5 into 10 power minus 3. Finally, 2 5s, 0.4 available. You will get 0.4 into 10 power 3 you can get. The finally RL is taken as 400 ohms I can put here now. So which option is correct? Which option is correct? Option B is correct, I can say. That is B option. That is the B. In case in a problem beta is given, we cannot assume the transistor is in what? Saturation mode only. As it is lacking, as we don't have the idea of what? But without beta, we cannot get the VCE value from the other wave only now. That's why we need to assume it is in saturation and we have to get the what now? Answer in this wave only now. Yes, 2.02 equal to 1.8, sir. What is that? I don't understand. 202 is 1.8, sir. What is that 2.02 equal to? I don't understand. Herculean, can you say once again? I don't understand clearly now. The VC voltage, sir. Yes, VC voltage is a 2 voltage only. Given in the problem, is it not? VC is nothing but the 2 voltage only. That is clearly given. This is nothing but the 2 voltage. This voltage is a 2 voltage. We are assuming the transistor is in saturation At the time it can act as a short circuit, theoretically they will call. When it is acting as a short circuit from here to here, we cannot find any voltage drop. No voltage drop is possible. 1.8. Yes, exactly. That is what I'm saying now. We subtract 0.2, we are saying 0.2, we consider it as a very smaller voltage only now. That voltage we are neglecting. It is not a mistake only now. Understand now? Even you have considered, it doesn't matter now. Which value it comes very close to you, watts? It comes very close to 400 only now. That's why what anyhow 0.2 drop is a very small. That voltage is neglected only now. In many books they will give clearly what? When the transistor is in saturation mode, it can act as a short circuit, theoretically they will say. Very practically I want to go, sir. At the time we can say the drop across, this is what now? Voltage is, this voltage is 0.2 voltage they will take. It is not a matter now. But as per this what now? Options, we are proceeding only now. As per the option, we need to proceed, it can act as a short circuit only now. Suppose it is not given the 400, some change is there now. At the time we can take according to what now? 0.2 voltage, we need to make the calculation only now. It comes answer only now. So anyhow, RL is 400 ohms, we can put only now. Understand my point now. 0.2 voltage drop, you are correct 100% only now. But the point is here, and one more way also they will say 0.2 is a very small, that is why they are going to neglect. They will say the transistor when it is in saturation, it is a short circuit also acceptable. It is not a mistake. Understand now. 100% you can take now. This way we can calculate RL value. Do you understand this answer? Did you understand the solution? Anybody has got any doubts regarding this problem? Regarding this problem, anybody has got any doubt? This way we can do. Understand? Next question. Next one. Yes, this is one more question. You take the time and give your answer. I will wait for some time. Please put an effort to get solution for this problem. You take some time. I want to wait for some time. Please write. Anybody can get answer? Here options are not given. BDS I want. You make an effort to get answer. Anybody getting answer? Anybody? It doesn't take more time. Maximum 1 minute to complete this question. Maximum 1 minute. Not required 2 minutes also to do this question. Shall I do then? Shall I do this question or shall I wait? Anybody can respond? Shall I wait or shall I do this question? If you are trying means I will wait for some time. If you are not trying means I will do. Which is best? You select. Yes, okay, it's better to start. You also do parallelly. Yes, Herculean. The think gate drain shorted short. Think gate and I think gate drain shorted. Gate and drain here now. This is nothing but the source and what now? Gate and source is here shorted only. Gate and source only shorted, is it not? No? Drain is not shorted. Gate and drain only shorted here now. That way it is done. Mostly many books you can find what now the short they will connect that side. But such a way not given. Here only it is given in this problem only. The problem is given such a way only. The gate and source are shorted. In that case only, we need to calculate required value. Okay, I will do, please watch. If anybody has got any doubt, means that will be cleared exactly by the end of this problem. Consider the circuit shown below. The transistor parameters are as follows. K equal to 0.2 milliamperes per square volts. Threshold voltage is given 2 volts. The value of VDS in volts is asking to find the VDS. Yes, MOSFET of 5 volts, sir. Exactly correct. That only concept. That only correct. Exactly correct. What you did is now. Now you are using the brain. Understand now? Yes, answer is 5 voltage, 100% perfect. What you did is a correct one now. Yes. Anyhow, here how we can do this question? The value of VDS is required. This voltage is asking to find. That voltage is required. In this problem, please try to catch my point. This is nothing but the gate. Gate to source voltage is nothing but this voltage only. Gate to source is this voltage. What is gate to source voltage here? Anybody? What gate to source voltage? Because it is shorted, 100% it comes 0 voltage only. Shorted, that is why VGS is nothing but 0 voltage. I can write VGS equal to 0 voltage we are having here now. VGS is 0. Yes, VGS should be greater than what now? Greater than what value it is given? Yes, I will give now. I will give anyhow. VGS is a 0 voltage. This node voltage we can call it as a source voltage only. VS I can write. This is VS. This voltage and 5 voltage is nothing but the drain voltage only, I can say. This is nothing but the drain voltage, I can say. The difference of this voltage only VDS we can say. VGS 0 means, what is the VS value here? VGS how much? VGS and VS are same only here now. Whenever you are applying the what now here, what voltage you can have? 0 only here now. VGS and VS are same voltage you can have here now. Same 0 voltage now. VGS and VS will be same. It won't be differed now. And finally, only one point we can say here now. In the problem, what is given here now? VTH is nothing but the 2 voltage here now. That point you try to catch. VTH is nothing but threshold voltage is given 2 volts only. And also in the problem, what a VGS, we got the 0 voltage itself. Whenever these two we are comparing, VGS must be what is required? VGS must be greater is required, then only it is going to operate. MOSFET is going to operate only now. But here we are not finding VGS greater than VTH. VGS is less than what voltage? Threshold voltage only we are getting. Whenever VGS is less than threshold voltage, here we cannot find any current in the network. MOSFET will come to the what now? Off state only now. That means no channel will be formed. No channel will be formed to have the current from what now? Drain to the source only now. At the time we can say here, we can VGS is less than VTH means no channel is formed. No channel is formed. When the channel is not formed means in the what now? Circuit, that means MOSFET is off condition only. Drain current is going to become 0 only now. 0 amperes only possible. Whenever the drain current is 0, what is going to happen? Now, current across 5K also 0, VS also 0 only. That's why VS and VGS 0 I said. Current is 0, drain current. This is a drain current means this is a drain current 0. Then VS also becomes 0 only now. Both are 0 only. Now, what is VDS? I can write VDS is nothing but VD minus VS I can write. What is VD, sir? VD is nothing but the 5 volts. What about VS, sir? VS is 0 voltage. Finally, we are getting the 5 voltage is the answer. So, what output voltage is available from this problem means 5 voltage only we can get only now. Followed or not followed? Once again, I am repeating. Gate and source is a what now? Short circuited. As it is short circuited, VGS is a 0 voltage only. When VGS is 0, what happens now? VTH is what? Greater than VGS. So, VGS is less than VTH. Less than VTH means MOSFET is in off state only now. Whenever MOSFET is in off state, MOSFET is the next state. ID is a 0 amperes. When ID is a 0 amperes now, Vs also 0. Finally, we are going to get the what now? VDS 0, 5 voltage only now. Yes, next question I will give, no problem now. I will give. That way we can get answer only now. Understand now? Yes, we can go to next question. Yes, this is one more question. Yes, please put an effort to get answer for this question. Please find solution for this question. Please find solution for this question. But I will wait for some time. Please complete this question. You take some time and give answer. What answer you can get from this question? But I want to see how many students can give answer for this question. Out of these 4, which option is correct? Please identify. Which option is right? You identify. Shall I do? Shall I wait? What's better? Yes. It needs 2 minutes, 100%. It requires 2 minutes to complete this question. Yes, I think it is better to do. You can compare my answer also then. Consider the common source circuit with a source bypass capacitor. The signal frequency is sufficiently large. The transistor parameters are VT n equal to 0.8 voltage. Threshold voltage is given anyhow. Threshold voltage is given 0.8 voltage. Kn is given 1 milliamperes per square volts and lambda equal to 0. The voltage gain is the voltage gain. Yes, which answer? What answer you gave it? B. I'll check. Answer is B is given by one student. Yes, B is correct. Exactly correct. What you need is a 100% perfect only now. Yes, I will do. Please watch. Consider the, but in this case, is asking to find the voltage gain. But in this problem, we no need to check. We no need to check whether it is in saturation mode or otherwise it is in the what? Whether it is in what now? K, exactly it is to be given K value only. Yes, exactly that is a correct now. Kn is given, K is a correct only now, exactly. By using the K only now, we need to find out now. K is nothing but 1, but it is written Kn, exactly it is a K only now, understand? Because then only we can apply K into Vgs minus Vt whole square only. Kn is given means ID formula will be changing only now, understand? It is a K only now, understand? 100% it is a K only now, understand? Now please watch. In this problem, we no need to identify whether it is in saturation or otherwise it is in what now? Triode mode, otherwise it is in the half what now? Cutoff mode, we no need to identify. Why, sir? Once in the analog circuit, he asked to find out the voltage gain means the MOSFET is in saturation mode only. Only when the MOSFET is in saturation mode, then only we are going to find the voltage gain only. Otherwise, we cannot get it only now. If it is taken transistor, the transistor must be in the active mode only now. That point is very important. Anyhow, we should assume it is in saturation mode only. Based upon that point, we need to move to the front only here now. Please watch initially. But I wish to find the what we have to find, drain current is more important. Sir, why it is required drain current? To find out the voltage gain, it is required transconductance. The transconductance you want to find means it depends upon the VGS. VGS depends upon the what now? Drain current only. But in the problem directly drain current is given 0.5 milliamperes only. Yes, we can put drain current is nothing but 0.5 milliamperes of current is passing this side. 0.5 milliamperes is passing here now. Once you know the drain current, you can measure. We are assuming it is in what now? Saturation only, 100% saturation only now. So ID equal to, we know, K into VGS minus VT whole square. I can write VGS minus VT whole square only now. From this one, I can measure VGS. VT means VT, but no threshold voltage only now. ID is nothing but 0.5 milliamperes. Yes, I can write 0.5 milliamperes. The K value is given as a what? 1 milliampere. 1 into 10 power minus 3 is given. 1 into 10 power minus 3 is given. VGS, we need to calculate. VGS, we need to calculate. VT is given 0.8. 0.8. Then you find what VGS. What is the VGS from this problem? What VGS is possible? Anybody? VGS you will get exactly 1.51 volts. If you are simplifying 1.51 volts, you will get that much voltage is possible. 1.51 voltage here possible. Sir, why this VGS is required? For the sake of finding the transconductance. Transconductance equal to what? dID by dVGS. Differentiation is required. 0.5 milliamperes given, sir. Yes, 0.5 milliamperes only have taken ID. 0.5 milliamperes only have taken. Yes, already 0.5 milliamperes. Yes, that one I am putting directly. ID equal to 0.5 milliamperes I have taken directly only now. From this problem only. From this problem only I have taken ID value. By using this equation, I am calculating VGS only here now. Understand? Drain current, what now? Drain current is already given. I don't need to do anything now. I am not doing anything. GM is nothing but 2K into VGS minus VT, just to differentiate. Once you apply differentiation, I can get the GM here now. In this problem, I can write transconductance GM equal to 2 into K. What is the K value given here now? 1 milli. 1 into 10 power minus 3 it is given. K is nothing but given 1 milliamperes per square volt. VGS we got 1.51. 1.51. What is VT? VT is nothing but 0.8. 0.8 we are getting now. Now we can get the value of GM. The transconductance we can get here now. What transconductance is you will get here now? The transconductance you will get exactly 1.42 milliamperes. 1.42 milliamperes per volts we can get now. That much amount of the transconductance is possible. Sir, what is the point of finding this transconductance, sir? Yes, we can give now. Now, by using this transconductance, we can find the voltage gain. For the given circuit, you draw. For the given circuit, you draw AC equivalent circuit. Once you got the AC equivalent circuit, we can determine voltage gain. How we can draw? Please watch. I will do. But initially it is connected with Vs. Source voltage is given. Wherever AC source is given, that must be taken as it is. Under AC analysis, Vs is to be taken as it is. That's connected to the ground. And also, what is given? 20 kilo ohms here given. Yes, I will note down. 20 kilo ohms here given. That I will connect as it is. 20 kilo ohms. I connected 20K. After that, what is given here? And also here the MOSFET you got now. In the MOSFET input impedance is very high, you can find. That connected because the current passing through the what now? Gate is approximately equal to 0 only possible. The resistance is very high. That is why gate to source must be open circuited only in the AC analysis. You must open circuit gate and source because current through the gate is approximately 0. That is why it is an open circuited now. This voltage I can note down VGS. This I want to take it as a VGS here now. And a MOSFET, what the MOSFET, whenever, what now, if you want to draw the AC equivalent circuit for the MOSFET means voltage with current source is a must, dependent current source. That current source depends upon this VGS. What we have to multiply this VGS to get the current? Whenever you multiply it with the transconductance, then I can get the current. GM into VGS is nothing but current only here now. But still in the problem, what is given, you watch. Here, under AC analysis, we are applying the AC analysis only. Under AC analysis, wherever the DC source you got, current source if you got, that must be open circuited now. Whenever the current source is DC current source is open circuited, means this totally open. Wherever the capacitor is given, that must be shorted only now. Wherever you got the capacitor, that must be shorted under AC analysis. Wherever the DC source, the DC current source you got means open circuit. DC voltage source you got means you must short circuit only. That only condition. Anyhow, at the source, the capacitor is shorted, it goes to ground directly, I can say. This is grounded directly. That's possible. And also, in the problem it is given, what is given here now? You please watch. But drain resistance 7 kilo ohms it is given. Wherever DC source is given, that must be shorted. At the time, I can get 7 kilo ohms here now again. Here 7 kilo ohm resistance I can get. 7 kilo ohms I can get now. And I have to receive the what now V0 from here only. This is V0. Voltage gain means V0 divided by Vs. All these grounds will be combined by a line. This is nothing but AC equivalent circuit. AC equivalent circuit I can say. By using this circuit, we can determine the voltage gain. How we can find? But I want to find the V0 at first. How we can find the V0? Voltage across 7K is nothing but the V0 itself. The resistance has to receive the current, but the current direction is given in reverse. Reverse means you must take sign with minus. Minus GM into VGS, I can note down, into what? 7K, I can put here now. Current into resistance only. Current into resistance now. But here, what is VGS? That is very important. But here the VGS and VS are in parallel. That is why VGS equal to VS I can put directly. So I can write VGS is nothing but Vs only. Those two voltages are same. And I can substitute V0 equal to minus GM. What GM we got already? GM equal to 1.42 milli. 1.42 milli we are getting. GM is 1.42 milliamperes per volts. 10 power minus 3. VGS equal to what I said? Vs. I can put Vs into 7 into 10 power 3 I can write here now. Here 10 power minus 3, 10 power 3 is cancelled and V0 by Vs you find. That V0 by Vs we are going to call it as a voltage gain for the given network. That voltage gain, whenever you are simplifying, that value comes as approximately it comes. Approximately it comes as, approximately you are going to get 9.9, exactly 9.94 is available, minus 9.9 we can write. Minus 9.9, that much value you will get only now. But in the options you watch it now, minus 9.9. So option B is 100% perfect in this problem. By using the DC analysis, we need to find the transconductance. By using the AC analysis, we are going to get the what now? Voltage gain. That way we can tackle the question. Yes, did you understand or not this question? Anybody has got any doubt regarding this solution? Anybody? Shall I go to the next question? Shall I go to the next question? Already 0.5 milliamperes given. That only I have taken, understand. Okay, next one. Yes, you please try this question again. The next question from the feedback amplifiers. Anybody can complete this question without my help? Asking sometime this type of questions also. Sometimes asking this type of questions also in the gate. Sometimes you can expect questions of this model also. Please try it and give the answer. Please try it and give the answer. What answer is possible? Anybody can give answer? Easily you can give answer. It's not a tough question, very simple question. Yes, please watch. I will do here now. If an amplifier with a gain of minus 1000 and feedback of beta equal to minus 0.1 had a gain change of 20% due to temperature, the change in gain of the feedback amplifier would be dash. 4 options are given. Which option is right? We need to identify. What's given in the problem? Please watch. If an amplifier with a gain of minus 1000, that must be taken as a what now? Without feedback, the gain whatever you got is A. This is taken A value. A is minus 1000 is given in the problem. And also what is given in the problem? Feedback of beta equal to minus 0.1. Yes, it is given beta also. We can note down beta value, minus 0.1. That much value is given. Had a gain change of 20% due to temperature. Because of the change of the temperature in the circuitry, he says the change in gain before feedback only now. Change in next one it is asking change in gain of the feedback it is given. There is a without feedback change in gain is a 20% only now. That means without gain means change in gain is denoted by dA by A into 100. It is a percentage value given in the problem. That is why dA by A into 100 we can put now. How much it is given? 20%. Because in the 100 into 100 only taken here now. That's why directly you can put 20. But don't divide by 100 again. Because dA by A into 100 I have taken 20 only now. And the problem is asking the change in gain of the feedback amplifier would be, the change in gain means DAF, change in gain after feedback only. DAF by AF into 100 equal to how much? Percentage is required. That value is asking to find only now. How we can find that value? There is a direct formula in feedback amplifiers. How we can apply? We know very well DAF by AF into 100 equal to, we know the formula. What is the formula? 1 by 1 plus A beta. There is a direct formula from the feedback amplifier. 1 by 1 plus A beta into what? dA by A into 100. There is a formula directly that I can write. This is the formula having. So by using this formula, you can determine the change in gain of the feedback amplifier here now. Yes, to substitute these values. 1 by 1 plus A is given here minus 1000. Yes, we can put minus 1000 here. Beta is nothing but here given minus 0.1. Yes, we can put minus 0.1. And dA by A into 100 is given as a what? 20 is given. I can put this equal to 20 into 20 I can put here now. Use the calculator. You are going to get DAF by AF into 100. You will get directly one. Asking this type of questions also in the gate. That value comes as 0.19 it comes. It is approximately equal to 2 it comes. Approximately equal to 2 it comes. Mostly 2% is possible here now. Approximately it comes 2% only now. Approximately equal to 2% you will get only now. Percent 0.2, sorry. Approximately it comes as a 0.2 I say. Mostly 0.19 you will get now. 0.19 is approximately equal to 0.2% only. But in the problem, what is given options? Yes, option C 0.2% we are getting. Option C is perfect only now. That way we can find the solution for this question now. Follow this solution. Anybody has got any doubt regarding this solution? Anybody has got any doubt? Shall I go to the next question? Yes, I will give one more question. Please watch. Yes, this is one more question. You try to think and do this question. You take 2 minutes and get answer for this question. I will wait for some time. Please tackle this question. But I want to wait for some time. Please try this. Initially, work is required on your side. If you got answer, very happy. If not getting, I will give explanation. Which option is correct? Please try this. Yes, I will do. Please watch. Otherwise, I will do this. Please watch. Match list 1 with list 2 and select the correct answer using the code given below the list. List 1 type of feedback is given. What they are given? A. Voltage series. B. Voltage shunt. C. Current series. D. Current shunt. And codes are given here now. But under list 2 is given R in. First one, R in increases and R out decreases. R in and R out decreases. R in, third one, R in and R out increases. Fourth one, R in decreases and R out increases. And finally, which code is perfect? We need to identify here now. Which code is perfect only now? How we can do this question? Listen now. No need to muck up any formula. Directly we can do this question. Here the type of feedback initially given in the list 1, voltage series. Voltage series is given. We know very well series indicates input circuit only. It indicates input circuit. Voltage in the first word indicates output circuit only. But whenever the input circuit is a series, in the series connection, resistance will be increased or decreased. In the series connection, resistance, total resistance increases or decreases. We need to think only now. Easily we can say, in the series connection, resistance is going to increase. That means, in this model, input means RIF. Input side RIF after feedback increases only possible here now, because it is in series. It is in series. And also what voltage is given, output circuit is the voltage. Voltage means you need to assume it is a shunt connection only. The output circuit is with shunt connection. How can you say it is a shunt connection, sir? Voltage, whenever the shunt connection you are having, voltages are same into resistors only. That's a voltage is specified in the problem at the output means you need to assume there is a shunt connection. Whenever the current is specified at the output, you think it's so. Current will be equal where? In the series connection only, you need to think. So now you tell me voltage indicates a shunt. At the time, the resistance in the shunt connection will be increased or decreased. You identify. This decrease only now. Shunt connection parallel. Their resistance decreases only. That's why ROF, output impedance, at the output will be decreased. First point. Which point is correct here now? The option what now? In the list 1, voltage series means which is right in the list 2? The list 2 you check it. What is given? RIF increases. RIN, RIF or RIN, no problem. Understand now. Voltage series means RIN. RIN increases. Exactly. Input resistance increases, he says. Okay. RIN increases. Even you have taken that same word, whatever it is given, that we can use, no problem. It is given here now what? RIN we can put now. Same word we can use best. Understand? No problem. That means RI, input resistance, RI I have taken increases, R naught decreases only. Yes, which option? RI increases, option 1, R out decreases. Yes, this is correct. So, first one it is taken with 1. 1 is existing in A and also what now? D also. 1, 1 we are having. So, maybe A, maybe D only. But not B and C. Not B and C. Reason is what? It is a 3, 3 is existing. It is not acceptable. Next one, voltage shunt. Voltage shunt means shunt indicates input circuit. This one. This is input. Voltage is nothing but output circuit only. We must take. But in the input circuit, what is going to happen now? In the input circuit, shunt connection, what happen now? Shunt means parallel. Parallel means what is going to happen now? Resistance is decreasing now. RI as per the given symbols. RI means after feedback only all these. RIF exactly means now. RI will be shunt connection. What happen now? RI decreases only now. Shunt connection. And also what are the voltage means? What is the meaning? I said now shunt connection only. In the shunt connection, R naught also what happens now? R naught also parallel decreases. Voltage indicates parallel. In the parallel connection, output resistance will be what? The resistance will be decreasing only now. That's why I can write which option is correct here now. R in and R out decreases. Yes, second one is correct. 100% second is now. That is the option D is correct here. We can say directly. 1 and 2 here only we are getting. The rest of 3 and 4 will come directly now. Otherwise, you got out means you can try again. What? Current series is given. Series is input here. Current is nothing but the output. Series indicates what we can say? RI increases. RI increases. And what the current indicates what? Series. Current is a series. Series means this also resistance increases. That means option C, R in and R out increases for third. For C, we can say this one only possible. Understand now. But this if it is taken now, this is correct only now. And voltage series if it is taken, this is correct only now. And last one you check it, current shunt. Current shunt is given. Shunt indicates input circuit. This is input circuit. Current indicates output circuit only now. In the shunt connection means parallel. Shunt means parallel. In parallel connection, resistance is decreased. Yes, resistance is R out. Input resistance is decreased. R in is decreases only now because it is a shunt connection. Current series. In series connection, what happen now? Output resistance increases only possible. That's why this is equal to this. Finally, which option is correct? Option D is correct only. We can say 1, 2, 3, 4 exactly we are getting now. So, option 4 is correct in this problem. That way we need to get the solution for the problem only. I hope you followed this. Understand? If there is any doubt, students can arise their doubts. Shall I go to the next question then? Shall I go to the next question? Yes, I will go there now. Yes, this is one more question. You make an effort to get answer for this question. I will give you time. Please get answer for this question. You take some time and give answer. What answer is possible from this problem? What answer is possible from this problem? Please try it. You can try. Which option? Options are not given. Is asking directly answer only now. Can you give answer? You put an effort to get answer. What way we can find V naught? You take some time and give answer. If not getting, I will do. Anybody getting answer? Any student getting answer for this question? Yes, I will do. Please watch. I will do this question. Please watch now. In the circuit shown below, if operational amplifier is ideal, it is given ideal op amp. Ideal op amp and ideal op amp and MOSFET parameters are mu n COX equal to 100 microamperes per square volts, VT equal to 1 volt, W equal to 10 micrometers, and L equal to 2.5 micrometers are given now, 2.5 micrometers. Then the output voltage V naught of T is dash volts. Is asking to measure V naught. What output is possible to get from this circuit? That is the question here now. How we can find? How we can find V naught of T from the given problem? That is the question. How we can find? To find the V naught of T, initially we need to find the drain current. The drain current is very, very important. Sir, why drain current is required? For the MOSFET, why drain current is required? Because to find out the V naught, this current is a drain current, means even this current also same current, drain current only possible. Same drain current. Why, sir? Because whatever the current it passes, same current will pass across 20K. No current is going to divert across what? No, operational amplifier. Reason is what? Input impedance of op amp is infinity only. That's why these two currents are same. That's why we need to find at first what is ID. Once you got the VD, what the ID value, we can determine V0 of T only now. And also one more point, the V plus is given 4 voltage here. When V plus is a 4 voltage, even V minus also same voltage only now. What voltage? Same 4 voltage you can have here. This voltage is a 4 voltage only possible. Once you got ID, directly you can apply the KVL in this direction. Directly you can apply the KVL in this direction. That means from here to here I can apply the KVL. I can determine V naught value directly now. But here the unknown value is nothing but ID here now. Once we know the ID value, we can determine V0 of T. So how to find that ID? So here we know very well this voltage is nothing but VGS, gate to source voltage, VGS, under DC analysis only. This is connected to ground, 0 voltage, we know very well. I will apply the KVL in this direction to find the VGS. Why VGS is required, sir? To find the ID value. When I apply the KVL, 0 volts equal to, yes, I can write 0 volts equal to, when I go this side, VGS plus VGS, here I will get. When I go to front, minus 2 voltage here available. So minus 2 I can put directly. So what is the VGS we can get from this? VGS is nothing but 2 volts. Yes, we got gate to source voltage is nothing but 2 volts. That is VGS value. Once you got the VGS, you can determine what value? ID value. How I can find ID? ID is nothing but, in the problem it is given, mu n COX is given, W is given now, and L also given. We know the formula. Drain current equal to mu n into COX divided by 2 into W by L into what? VGS minus VT whole square, we know. By using this formula only, we can determine the drain current only. From the MOSFET, we know the formula. But in a problem, mu n and COX, every value is given. Directly you can substitute here now. Mu n into COX is given 100 micro. This is 100 micro. 100 into 10 power minus 6 we got. Divide by 2. Divide by 2 into W. What is the W value? 10 micrometers. I can put 10 micro. 10. Micro both are cancelled now. L also 2.5, micro only now. So micrometers cancel. Divide by 2 I can put. This is a 2.5. Divide by 2.5. Then VGS we got as a what? 2 voltage. I can put 2 minus threshold voltage is given in the problem 1 volt. Yes, I can put that value is nothing but 1 whole square. Use the calculator. You are going to get the drain current here directly. What drain current you can get from this problem? Please check it. The drain current comes as 0.2 milliamperes. If you are using the calculator, you will get 0.2 milliamperes. That much amount of the current is available. This is the drain current you will get from this. That is the drain current. Once you got the drain current, you can measure the V0 of T. I can say this V0 of T, just I want to apply the KVL in this direction. Yes, I can find V0 of T from the given problem. How I can find? When I go this side, 20K into ID here. Yes, I'll write 20K, 20 into 10 power 3 into ID. ID is nothing but 0.2 milli. 0.2 milli we are getting 0.2, 20K into 0.2 milli plus 4. Yes, we can write plus 4. And 10 power minus 3, 10 power 3 this cancel. 20 into 2, we are going to get what now? Simplify this value. 20 into 0.2, we are going to get the what now? 4 volts plus 4. 4 plus 4, we are going to get the 8 volts is the answer of this problem. Yes, finally answer is 8 volts. That is the answer for this question. V0 of T from the given problem is 8 volts. Did you understand or not? Anybody has got any doubt regarding this problem? If there is any doubt, immediately you arise your doubt. You can arise. Just by applying the KVL, we are getting the V0 of T. That is the solution of this problem. Taken this? And we can go to next question. Yes. Please try this question. This is the one more good question. From the transistor. From the transistor, this question is given. You take your time and complete this question. You take some time and get answer for this question. What answer you can get from this? What is the answer for this question? Please try it. Please try this. Anybody can give answer? Anybody can respond? Yes, I will do that now. What is given here? For the circuit shown below, the Q point is VCE Q equal to 12 volts, IC Q equal to 2 milliamperes. It is given, I think 2 milliamperes. And beta is given at beta equal to 60. The value of resistor RC and RB are is asking to find RB and RC values. These two values are required. How we can find is more important. How we can find RB and RC in the problem? You watch it. When the supply voltage is given 20 volts, it's going to flow this side. Current of IC, everybody knows. Current across RC is nothing but IC. Current across RB is nothing but what? IB. The name of this network is nothing but fixed biasing only. From the fixed biasing, question was asked. Here IB and IC here now. In a problem, it is given directly. VCE Q is given. This voltage is given. 12 voltage. This voltage is given 12 voltage. And IC is given, ICQ means IC, how much? 2 milliamperes it is given. This current is given 2 milliamperes only. Beta is 60, RB and RC required. Directly we can determine RC value. How we can find RC? Input we know here now, 24 volts. From here to here is nothing but the 12 volts divided by current. Then I can find the RC value. I say RC is calculated by input side voltage 24 here now. Yes, I can take, there is a 24 minus 24 minus this voltage is a 12 voltage. I can put 12 voltage this side. Divide by current IC 2 milliamperes. 2 into 10 power minus 3. Now we can find what is RC from the given problem. You will get 24 minus 12 is nothing but the 12 by 2 into 10 power 3, 10 power minus 3. So on simplification, RC value is 6K you will get. Yes, RC is nothing but 6K we are getting here now. 6 kilo ohms we are getting only now. Yes, now you try to find the RB value. I got the RC value. You try to apply the methodology and try to find what RB we can get. How we can get RB? Initially we need to know what is IB. Base current is more important. Without base current we can't do. First you find what is the base current. Once you got the base current, you can measure the RB value. We know very well base to emitter voltage is nothing but 0.7 voltage, no doubt. This voltage is 0.7 voltage. I am in need of RB. To find the RB, IB is must. How we can find IB? IB is nothing but IC by beta. Collector current by beta. Formula we know. What is IC? IC is already given. How much? 2 milliamperes. Yes, I can write 2 milliamperes. 2 into 10 power minus 3. And beta is given as 60. Yes, I can put beta is 60. So I can cancel 230. Use calculator. How much IB you will get? What IB you will get? IB is nothing but, it comes as 33.3 microamperes. 33.3 microamperes you are going to get. If you are using calculator, 33.3 microamperes of current is going to pass only now. Once the base current is known, you can determine RB value. How we can determine RB? You please watch. RB is calculated by, RB you can get from what? RB equal to this voltage, input this voltage minus this voltage by current itself. So I say RB is calculated by 24 volts. This side is a 24 minus this side is a 0.7 volts. Yes, I can put 0.7 volts divide by what? Current IB. What current is passing? 33.3 microamperes it is passing. 33.3 microamperes it is going to flow. Finally, we can get RB value here now. What RB value is possible here now? RB comes as a 699 kilo ohms. 699 kilo ohms you are going to get now. Which option is correct? Option C is correct. We are getting the what now? RC 6K and also RB equal to 699 kilo ohms now. That way we can find the what now? Answer for this question. Anybody has got any doubt regarding this problem? If there is any doubt, please arise. If anybody has got any doubt, they can arise their doubts. Anybody? Did you understand this question? Solution you followed, I think now. That way we can find now, understand now. So yesterday we have done the problems what? I selected initially diode. By using the diode, I have done basic diode, configuration I gave it. There onwards, we got the solution. Next, I gave it one clipping circuits I tackled there now. Next one is nothing but the clamping circuit I have done. Problem on the transistor we have done. GNR diode we have done. Transistor with a GNR, how we can do that also done. And also I did the what now 2 questions from the feedback amplifier also. In this session, we completed what now we did here now operational amplifier problems we have done, and also certain questions from the what now feedback, and also from the MOSFET we have done now. These are the model questions for this today session only now. Understand now. Thank you then. We can complete this session today.